ये है ना, इसमें ये आ रहा है। नहीं, ये हाइट है।
ये दिया है मैंने, शेयर भी कर दिया मैंने। Hello, good morning to you all. Yesterday we discussed about two applications. One is electric field due to a straight line conductor, and second one is electric field due to a charged infinite sheet. Now today we will discuss the next one, field due to a uniformly charged spherical shell. Field due to a uniformly charged spherical shell. First of all, you have to understand that what is shell. Shell means a hollow sphere, just like this one. Shell is a hollow sphere, and for this hollow sphere, if it is uniformly charged, that means charge is distributed over the spherical shell like this one. And hollow, there is no material within this one, and outer part of the spherical shell is also going to be free from this material of the spherical shell. Now we are discussing about the electrical field due to the spherical shell. For that purpose, what we have to do, we have to suppose a spherical shell of radius capital R. Okay. Now if you see this spherical shell, then three areas or three zones of this spherical shell is clear to you by picture. First one is this one, outer. Okay. Second one is surface, and third one is inside. These three parts, these are having different properties. If you go for the outer, whole of the charge is taken into consideration. If you go in at the surface, the spherical shell itself behaves as a Gaussian surface, and inside there is no charge. That means electric field is different for all these three. For that purpose, what we have to do, we have to divide this into three parts and calculate the electric field intensity with the help of Gauss law for all three parts separately. So, let us consider a spherical shell of radius r having surface charge density due to charge Q. First of all, what we have to consider outside the shell. When you are going outside the shell, that means our consideration is for small r is greater than capital R. Capital R is going to be the radius of the spherical shell, and we are considering the outer side of this spherical shell. That means this small r is greater than capital R. Okay. Now, for the purpose, if any point, suppose this is our spherical shell of radius r charged with this one, and any point of consideration here is like this one. This is point of consideration. to find out electric field at this point of consideration, which is at small r distance. Keep in mind that this small r is greater than capital R. What we have to do, we have to assume the Gaussian surface. The first step is there. Direction of E is here need not to be calculated because E is radial due to charge of this spherical shell. ये रेडियल डायरेक्शन में होगी और उसको हमें कैलकुलेट करने की जरूरत नहीं है, जैसा हमने किसमें किया था, स्ट्रेट वायर में किया था या इनफाइनाइट शीट के लिए हमने E का डायरेक्शन कैलकुलेट किया था। या सिंपली रेडियल डायरेक्शन में होगा और रेडियल डायरेक्शन में अगर r डिस्टेंस पे हमारा कोई पॉइंट ऑफ कंसीडरेशन है तो इस पे कैलकुलेट करने के लिए हमको क्या करना पड़ेगा, गॉसियन सरफेस को एज्यूम करना पड़ेगा एंड दैट गॉसियन सरफेस इज गोइंग टू बी ए concentric sphere like this one. It is going to be a concentric sphere of radius r and at which we are having this surface element as ds and E direction of E is perpendicular to it. What we have to do, we have to just assume a Gaussian surface. For outside, assume a concentric Gaussian surface. And for that one, small r is greater than